my name is Shazibra binti Zubey. I'm from EC1101K. So I will explain about how to answer the question application of integration.
Hi, my name is Nur Kamarina Arisa binti Rosidi. I am from EC1101K and I'm gonna explain about a problem statement. What are the common mistakes that students always do?
Hi, Assalamualaikum. My name is Nurul Ala Natasha binti Muhammad Nasir and I am from a group EC101K. In this video, we will explain to you about the application of integration. Okay, first, let me tell the introduction in this topic. What is integration? Integration is the act of bringing together smaller components into a single system that function as one. It is the inverse of differentiation. What is integration used for? It used for the process of finding integrals is called integration. Along with differentiation, integration is a fundamental operation of calculus and serves as a tool to solve problems in mathematics and physics involving the area of an arbitrary shape, the length of a curve, and the volume of a solid, among others. Okay, this is the example for the basics integration. So, this is the common formula we always use in the integration. This is called as power rules. Okay, first we need to know what's the value of n in this equation. In this equation, the value of n is equal to 3. Okay, so we just put it in this formula. So a is 2, okay, n is 3, so plus 1. Okay, so this is the answer that we got. And c, don't forget to plus c. Okay, so this is just the answer for this basic integration. In the application of integration, it has two subtopics. First is the area between two curves. Second, volume, solid of revolution. Under the solid or under the volume, it has three methods that we use. First is this method. This method is for calculating the volume of a solid revolution of a solid state material when integrating along an axis parallel to the axis of revolution. Next, the washer method. The washer method is similar to the disk method, but it covers solid of revolution that have holes where we have inner and outer function, thus inner and outer radius. Shell method is for finding volume of a solid of revolution uses integration along an axis perpendicular to the axis of revolution instead of parallel. The nice thing about the shell method is that you can integrate around the y-axis and not have to take the inverse of function.
Problem statement. The region R in the figure is bounded by the curve y squared equal to 1 minus x and the line y equal to x plus 1. Question A1. Find the coordinates of A and B. Question A2. Find the area of the shaded region R. Question B1. Find the volume of solid generated when the shaded region R is revolved about the line x equal to 1 by using the washer method. Question B2. Find the volume of solid generated when the shaded region R is revolved about the line y equal to -2 by using the shell method.
Assalamualaikum warahmatullahi wabarakatuh. So now I will show you guys how to answer for the question of application integration that usually come out in our test. This is the example of past equation MAT138 December 2018. So stay tuned. Okay, so for the first question, which is to find the coordinate of A and B. Did you know about what is coordinate? Coordinate is the position of the point on line X and Y. For example, in bracket of A, B. So A is the point on line X and B is the point on line Y. As you can see, there are two equations on this diagram, which is the y equal to x plus 1 and y squared equal to 1 minus x. The first thing we need to do is separate off this equation into the first equation and second equation. You can choose any equation that you want. For example, I choose y equal to x plus 1 as the first equation, and the second equation is y squared equal to 1 minus x. And then you make the first equation equal to second equation. But before that, make x as a subject. Okay, just switch the position of x and y as long as x as a subject. Okay, so yeah, replace the equation. Okay, replace the one with the equation, the first equation, which is the y minus 1 equal to 1 minus y squared. Okay, and then you change position and make this equation equal to 0. And then what you need to do is just factorize because you want to know the value of y. When you already know about the value of y, just make the when y equal to 1 and replace this value of y into the first equation, which is the y equal to x plus 1. Okay, when you replace, and you will get x equal to 0. And then you will get the coordinate of A, which is the 0, 1. Okay, so for the coordinate of B, you just using for another value of y and make it like when y equal to negative 2. Okay, as same as before, you just need to use the first equation, which is the y equal to x equal to y minus 1. Okay, replace the y and then you will get the value of x, which is the x equal to negative 3. The coordinate of B is negative 3, negative 2. Okay, that's all the answer. Okay, so for the second question is find the area of the shaded region of R, determining the area between x equal to fy and x equal to gy. So this is the formula of the area of shaded region by using the dy. Okay, why I say this diagram using for dy is, let's say you want to using for the dx. Okay, you don't know about the value of x here. Okay, so make it easier just using for the value that you already know, which is the y. You already know the value of y here, and you already know the value of y here. So according to the formula, right function. So what is the line on the right? Okay, so the curved line is on the right and the straight line on the left. Okay, so just replace the equation, which is the right function. Okay, y minus y squared, and the left function is y minus 1. Okay, and then integrate the first equation, okay, which is the y, which is the, for example, of 1. When you integrate, you will get for the y, and y squared, when you integrate, you will get y cubed over 3. Okay, so the second question is why you integrate y, you will get y squared over 2, and why you integrate 1, you will get y. Okay, so next one, just replace the value of a value of b, which is 1, okay, which is 1, and the second one is replace the value of a, which is negative 2, minus, and the second equation, okay, just replace the value of b, which is 1, and replace the another value, which is negative 2, and then you just minus of the value of this equation, which is 0 minus negative 9 over 2, and we will get for the area of the shaded region of R, which is 9 over 2 unit square. That's all. Okay, so for the next question is find the value of the solid generated when the shaded region R is revolved about the line x equal to 1 using the washer method. So this is the formula of the washer method. Okay, f at is the equation that far away from the line revolve, and the g at is the equation that near to the line revolve. Okay, k is the line of revolve and k is the line of revolve. Okay, make it simple. Just separate of this formula into the two categories. For example, this is the first categories and the second categories. Okay, for the first categories is y integrate sine in bracket of y minus 1 square dy. Why I say y equal to 1 as a g at f as of f at is because of y equal to 1 is the equation that far away from the line revolve, and 1 is the value of k, which is the line of revolve. Okay, just expand of this equation, I will get for the y squared minus 4y plus 4, and then integrate the equation y squared minus 4y plus 4, and we get 4y cubed over 3 minus 4y squared over 2 plus 4y, and replace the value of BA, okay, BA, which is 1, negative 2, into this equation, and the the value of the first categories is the 21 pi, and the second categories, okay, pi integrate sine in bracket of 1 minus y squared minus 1 square dy. 1 minus y squared is the equation that near to the line revolve, and 1 is the line of revolve. Okay, and then just expand of this equation, okay, and we'll get for the y 4. Okay, and then what you need to do is just integrate of this equation, and you will get for the y 5 over 5. Okay, next step is just replace the value of b and a, okay, which is the 1, negative 2, into this equation, and you will get the value of second categories is 33 over 5 pi. Okay, according to the formula, the first categories will minus to the second categories. Okay, so the 21 pi minus 33 over 5 pi equal to the 72 over 5 pi unit cube. So this is the answer for the value in question B1. That's all. Okay, so for the last question is find the volume of the solid generated when the shaded region R is revolved about the line y equal to negative 2 using the shell method. So this is the formula of the volume by using the shell method. 2 pi integrate sine ry cy dy. So how you want to know about the value of the ry? So top minus bottom, and cy is right hand function minus left hand function. So the first one is ry. So what of the equation of top? Okay, you don't know about the equation of the top. Okay, just replace of the top with the y, and the equation of button is y equal to -2. Okay, about the line revolve. Okay, y -2. And then you will get the equation of ry, which is the y plus 2. And then for the cy, right hand function minus left hand function. What of the equation right hand function? Okay, the right hand function is the 1 minus 1 minus y squared, and the left hand function is y minus 1. And then just solve this question equal to 0, and then you will get the equation of cy. And then according to the formula, 2 pi integrate sine y -2 because of dy. Okay, ry y plus 2 and cy y squared plus y -2. Okay, and then just expand this kind of uh, equation, and then you will get the negative y cubed minus 3y squared plus 4. The next step is integrate this equation, okay, and then you will get for the negative y over 4 minus 3y cubed over 3 plus 4y, okay, and then replace the value of b and a into this equation, and then you will get for 2 pi 27 over 4. Okay, and then the last answer is when you times 2 times 27 over 4, and you will get for 27 over 2 pi units cube. That's all.
So, as the conclusion, common mistakes. In application of integrations, students always make common same mistakes during the solution. Some common mistakes are being careless or use the wrong formula. So, solution is first, students have to use the right formula. Second, students have to key in the right integral. Third, count it for many times to see the calculations are same or not. Notes: area under the curve. Note that we may need to find out where the two curves intersect to get the limits of integration, and sometimes we have to divide out the integral if the functions cross over each other in the integration interval. What's the method? Note that for this to work, the middle function must be completely inside or touching the outer function over the integration interval. That's all from us. Thank you.